Again, as we do these, they get a little more challenging, and then they're going to get a little easier. But again, you have to read it carefully. So let's work on this one. If 15 less than 2 times a number. So we're going to let n equal the number. 2 times the number less 15 is divided by 6 more than the number. There's the number plus 6. If 15 less than 2 times the number is divided by 6 more than the number, so again, it took me a while to figure that out myself. You have to read it carefully. The results is 4 less than 9 times the reciprocal of the number. We had said the reciprocal of the number was 1 over n, and if we multiply this by 9, it becomes that. So 9 times the reciprocal of a number, but then 4 less. So there's the equation that I got. So you can pause the tape, read it over again, look at it, but now we want to solve this. And this is rather difficult, because what's our common denominator here? Well, our common denominator is this and this. So we have to multiply everything by n, and n plus 6. And I'll use this technique of putting it just out here, but multiplying each term by this. So here, these cancel out, but I still have to move the n here. So this becomes 2n squared minus 15n. So this cancels out, and I need to multiply the n times this and the n times this. Now here the n cancels out, but I have to multiply the 9 times n, and 6 times 9, I believe, is 54. And then minus, now I have to multiply this, which is going to be n squared plus 6n times a negative 4. So I'm going to write that out over here. There's my negative 4 times n squared plus 6n. Okay, I probably could have done it in my head, but I want to be sure I get it correct. So this over here is going to be a negative 4n squared. This is going to be a negative 24n. And then bringing down the rest of my terms here. And we can leave that side. Swap, we'll write it again. Now we want to have our n's positive, our n squared positive anyway. And since this is a quadratic equation, I have to put it in standard form. So I can then factor it. I'm going to work on this and then come back. Okay, so I brought my negative 4n squared over to the other side and got a positive 4n squared, which became a 6n squared. I kept that there. I added a positive 9n and a negative 24n and got a negative 15n. And then there's just my 54. Now, interestingly, these, as I add 15n to both sides, these just cancel out. I'm going to bring my 54 over to this side as a negative 54 equals 0. And there's my equation. I'm going to divide by 6. Here the 6 cancels out and I get n squared minus 9 equals 0. So I have the difference of perfect squares, and the difference of perfect squares, you recall, I'll move it over here, will factor into n equals, well, let's factor that, n plus 3 and minus 3 equals 0. And now my solution set would be n is a negative 3, n is a positive 3. And that's my solution set. And those check out. Again, this was rather difficult and lots of stuff to it. So as we continue on topic 6 of chapter 7, we're continuing with the word problems. Here, this type of problem is called a work problem. People are doing work, and I've shortened it, but I have the essence of what's needed. It says George can do a project in 3 hours. Pete takes 4 hours to do that same project. How long will it take if they're working together to get the job done? So again, they're working, and for this we need to know what the rate of each person is. Now for George, he gets something done in 3 hours, so his rate is 1 over 3. He gets 1/3 of the job done in 1 hour. So that's his rate. Now Pete's rate, it takes 4 hours to get the job done, so his rate is 1 out of 4. So in 1 hour he gets 1/4 of the project done. Now the basic formula is how much time would it take if they work together, and we don't know that. So that's going to be 1 out of t. So this is the basic formula for problems like this. You're going to get some problems in which they have it a little different, but we'll take a look at those as well. So again, what's our technique for solving this? Well, we want to get rid of the fractions. So we're going to multiply everything by the common denominator. And I could say 12t, but I'm going to say 3 times 4 times t, 3 times 4 times t, 3 times 4 times t. And you'll see why, because now the 3's cancel out, the 4's cancel out, and the t's cancel out. So I now have 4t plus 3t equals 12. So something that started out as something difficult again, when you know the recipe for putting it into an equation and then getting rid of your fractions, which we've worked on quite a bit, you end up with something like this. Now you're going to group like terms. Going to divide both sides by 7. So t equals, now what you can do is 7 goes into there once, 7 and what is left over is 5. Now, I would accept it as an improper fraction, but this is a mixed number, and of course this is ours. Now if they wanted minutes here, for the 5/7, you would go 5/7 of 60, 60 minutes in an hour. Again, multiply that by 5 times 60, divide by 7, that would give you the minutes.